Hey guys, Mr. Milton here. Today we're going to talk about triangle inequalities. At the end of this video, you should be able to list angles and sides of a triangle in order, and you should be able to determine the possible side lengths of a triangle. Alright, start with a couple theorems, and then we can use these throughout the semester, and even when we're finding measurements later, to check our answer. So our first theorem here, it says, if two sides of a triangle are not congruent, then the larger angle lies opposite the larger side or longer side. Okay, so bigger the side, that means that the angle that opens to it should be larger. So our directions, and this is really important as you're reading problems for the directions, as you're doing these problems, that you read the directions carefully. I'm going to say list the angles in order from least to greatest. Alright, so we're listing the sides from least to greatest. The angles from least to greatest. Now they gave us the sides, and you see that KL is 2.7, KM is 4.3, and LM is 5.8. Our theorem says that if the sides aren't congruent, which these aren't, then the larger angle lies opposite the longer side. Okay, so the least angle would be across from the shortest side. So our shortest side is KL, is 2.7. And so the angle it opens to is angle M. So angle M is our least angle. Okay, second would be the angle that opens up to 4.3, so angle L be next, and then angle K be final. Okay, now notice you can only arrange these angles. Using this theorem, you can only arrange these angles. You can't find the actual measurement of each angle. Okay, so another type of problem like this, it says in triangle PHT. So I'm going to draw a triangle PHT. It really doesn't matter how it looks. They're giving us measurements. In triangle PHT, they tell us that PH is 16 centimeters. TP is 20 centimeters, and TH is 13 centimeters. Okay, so I've labeled the sides, and that's the thing that I would tell you to do anytime that you have a problem that give you a description. Draw it out, label the sides. Alright, it says list the angles in order from largest to smallest. Again, important for us to make sure we're looking at the directions. So this is saying largest to smallest. Our largest side is 20. The angle that opens to it, or is opposite of that side, is angle H. Okay, next will be angle T, 16, and then finally angle P. Alright, so there we go. Largest angle is going to be opposite the longer sides. Alright, so theorem 2 is kind of the opposite. If two angles of a triangle are not congruent, then the larger side lies opposite the larger angle. Okay, so just the opposite. If we can say that, hey, if we know the sides, we can arrange the angles. Same thing, if we know the angles, we can arrange the sides. So this last question asks us to do that with this triangle. Notice in this triangle they only give us two angles. They gave us 45 and 75, and that's really all we need in order to know what angle M is. So that gives us 120. That'll give us 60. Okay, so now we know all three of our angles, and now I can list the sides from smallest to largest. So smallest side should be opposite the smallest angle. So our smallest angle is 45. The side opposite that is MN. Our next is 60. The side opposite of that is ON. Our next is 75. Side opposite of that is MO. Okay, again, we're just looking at this and we're saying, okay, the angle opens up to what side? Okay, so you see this angle, it opens up to this side. Alright, so pretty straightforward there. It says list the sides of triangle DVQ in order from longest to shortest. Alright, so DVQ, draw DVQ. They tell us that angle D is 51 degrees. They tell us that angle V is 4x plus 3. And they tell us that angle Q is 5x minus 18. Alright, good. Adding a little bit of algebra to this. Again, in a triangle, we know that all the angles should add up to 180 degrees. So we have, we can add these angles together. 4x plus 3 plus 5x minus 18 plus 51 should equal 180. Subtract 51 from both sides and add our like terms. So we have 9x minus 15 equals 129. Add 15 on both sides. 9x would equal 144. Divide by 9, x would equal 16. Just making sure. Okay. Alright, so we find that x is 16. We can use that to find out what these angle measures are. So this one will be 67. This one would be 80 minus 18, 62. So angle Q is 62, angle V is 67. And so now that we have those angle measures, we can find the size from longest to shortest. So the largest angle, 67V, and so its side will be DQ. Next should be DV, and then finally BQ. Alright, add a little bit more thinking here as we are given two triangles, share a side QR, and then it asks us which side is the shortest in the diagram. So I want to look at these triangles kind of separately here and say, okay, which side is the shortest? Well, I need to know the angle measures. This is an isosceles triangle, and so we have 180 minus 30, have 150 degrees left, split between these two evenly, and so that gives us 75. Both of these are 75. So I can see here that QR is the shortest side of PQR. Alright, now as I look at this other triangle, I have 40 here, 90 here, 40 plus 90 is 130, 180 minus 130 leaves me with 50. Alright, as I look at this triangle, the shortest side of this triangle should be opposite the shortest angle, so this is the shortest here. Now, I have to compare these two short sides. Is QR shorter or is RS shorter? Well, RS will be shorter in this case because QR is the side of this triangle, and we're saying that RS is shorter than it. So RS should be the shortest side. Okay? Alright. So there we go. There's comparing or being able to list the sides and the angles based off of their angles and sides. Alright, so triangle inequality theorem. It goes like this. The sum of the lengths of any two sides of a triangle is more than the length of the third side, or greater than. The sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So what the theorem says is, basically, if I add two sides together, it has to be more than a third. A plus B is greater than C. A plus C is greater than B. B plus C is greater than A every time. Okay, and this allows us to find the possible length of a triangle side. again, another way for us to kind of check our answers as we look at triangles and lengths and stuff. So it says, can a triangle have the given lengths? Now this is how we can do it. We could set this up for each triangle. So let me draw this triangle out. Okay, we'll call it A, B, C. And we could say, okay, 4, 6, 9. And we could go through each and every one of these and say, okay, 4 plus 6 is greater than 9, 10 is greater than 9, works. Okay, we could do 4 plus 9 is greater than 6, 13 is greater than 6, works. And then we could do 6 plus 9 is greater than 4, 15 is greater than 4, works. Okay, so can a triangle have these side lengths? Yes. Alright. Now, that's a lot more work than I really feel like would need to be done. So the way the shortcut, instead of trying all three of these things out, is just take the two smaller sides and say, is the sum of the two smaller sides greater than the larger side? Okay. The largest side in itself is always going to be greater than that third side. Okay. So take the two smallest sides in this triangle, and I can say, okay, 3 plus 7 is greater than 12. 3 plus 7, 10. Is 10 greater than 12? No. Okay. So this can't work because the sum of two sides isn't greater than the third side. So as soon as you find one that doesn't work, you're done. Okay, and we don't have to do 12 plus 3 is greater than 7. 12 plus 7 is greater than 3. And waste our time with those other inequalities. Take the two smaller sides. If that's greater than the third side, then it works out. Okay. All right. Next, we are looking at C. You try that out. See if it works out. We'll talk about it in class tomorrow. All right. Finally, it says the length of two sides of triangles are given. Find all possible lengths for the third side. All right. So when it says all possible lengths, it's not asking for one number, so we're not getting an equation. This is actually an inequality that they're asking for. And we're going to take this triangle inequality theorem into consideration as we find these sides. So we have to think of the two possibilities. We have to think, okay, what is the largest number that this can be? And what is the smallest number that this can be? And this is how we look at it. I'm just going to call this side x. Okay, we know that 7 plus 9 has to be greater than x. The sum of two sides has to be greater than the third side. And we know that the sum of the two smaller sides, x plus 7, has to be greater than 9. So we set up these two inequalities and solve them, and their solutions will be our possible lengths. So as we set these up, x has to be less than 16, and x has to be greater than 2. So we could write this as just x is less than 16 and x is greater than 2. Or we could write it as a compound inequality and saying that x is greater than 2 and less than 16. Either of these is acceptable as an answer for you to write, but you need to make sure that you can recognize both of these as well, just in case the answer is presented in a different way. Okay? Let's try that again with B. Again, we're looking at the two possibilities. What's the smallest that this number can be? Well, I know that whatever x is, when I add it to 14, it needs to be more than 23. And I know that whatever x is, when 14 and 23 are added, has to be less than that. Okay, so now we have this inequality. X has to be greater than 9, and x has to be less than 37. So x is greater than 9 and less than 37. Okay, notice This is not or equal to. Okay? 37 is not a solution for this. 37 cannot, x cannot be 37. It would not work out. X cannot be 2 because 2 plus 7 is not greater than 9. But x could be greater than 2 because anything greater than 2 works. Okay, so notice that as you look at the triangle inequalities. Alright guys, that's the first semester. See ya.